Hey, this is Dr. Holt. I want to go over higher order homogeneous differential equations, constant coefficient. This is part one of two parts of a video on this. Part one are going to be higher order differential equations where we do not have to put them in the polar form. Part two will consist of higher order homogeneous differential equations that we have to put in the polar form. I'm going to show you, I think it's about 4 to 5 problems here, and then when I do the second part, I'm going to work a couple problems here. We're going to look at the first one. On this example, we have y going to the third derivative minus 4. I need to put a prime there too, sorry. Y going to the first derivative. We're going to solve this. Okay, what I'm going to recommend on this one is go ahead and write this in terms of lambda. Some other textbooks use different terms. It really doesn't matter. And we're going to set that equal to 0. What we're going to do here is we're going to pull the greatest common factor out, which is going to be a lambda. That's going to give me a lambda squared minus 1 is equal to 0. And now what you want to do here is you want to solve for it. So you know that lambda is going to equal to 0, and you know that lambda squared is going to equal to 1. So lambda is going to equal to plus or minus 1. Again, you got to make sure you get the plus or minuses in there. So we have two solutions for this higher order differential equation. So we'll go ahead and write our solution. So y is going to equal to, and I'm going to go ahead and show the e. You don't have to in this case. Oops, let me do this. I need to put that c1 first. c1 times e to the 0 power plus c2 times e to the negative t plus c3 times e to the t. All right, and then I would rewrite this as y is equal to c1 plus c2 e to the negative t plus c3 e to the t. All right, and that's the solution for that higher order differential equation. Also, you note there are no conditions given, so there's no way we can solve for what c1, c2, or c3 would be in this one. All right, let's look at another example. The other example that I've come up with is this differential equation here. We have y going to the being third prime plus y double prime minus y prime minus y. All right, we're going to go ahead and solve that one. Again, we're going to go back to lambda cubed plus lambda squared minus lambda minus 1 is equal to 0. Okay, what you're going to do with a problem like that is you're going to group this. We're going to group it here and here. Okay, again, pull the greatest common factor out of here, which is going to be a lambda squared. That's going to give me lambda plus 1. Again, you want this to be the same, so I'll pull a minus 1 out of here. That's going to give me lambda plus 1. And that's equal to 0. We'll go ahead and rewrite that as our factors as lambda squared minus 1 times lambda plus 1 is equal to 0. Okay, we'll go ahead and solve this. We got lambda squared. We're going to move the 1 over. That's going to give me equals to 1. We're going to move this over. Lambda is equal to negative 1. So we got that one. We'll go ahead and solve this again. Lambda is equal to plus or minus 1. All right. Now you note something here. This is where students can make a mistake, is you have two negative i's. So you should go ahead and write out all the possibilities. So lambda is equal to 1. Lambda is equal to negative 1, but I got two of those things. I got repeated roots of 2. So what you want to do with a situation like that is write y is equal to c1. We'll go ahead and do this one first, of e to the t power. Now we got plus c2 of e to the negative t. And I'm going to write this wrong. I've seen students do this. c3 of e to the negative t. You can't do that. Since you have a repeated root, you have to put one additional t into there. So that would be your answer to that differential equation. All right, let's keep going. Let's look at another one. Again, these are somewhat similar. Let's look at this differential equation. Let me slide this over a little bit. We have y triple prime plus y double prime plus 4 prime y plus 4y. Again, we're going to write that in terms of lambda. We're going to get lambda to the third plus lambda, oops, not a very good lambda though. Let's do that better. Lambda squared plus 4 lambda plus 4 is equal to 0. Again, group this one here and group it here. We'll pull this one out. That'll give me a lambda squared that we can pull out of here. That'll leave me lambda plus 1 inside. We'll pull a 4 out of here. That's going to give me a lambda plus 1 is equal to 0. That's going to give me lambda squared plus 4 times a lambda plus 1 is equal to 0. Okay, we're going to let's go ahead and solve for lambda squared plus 4. That's going to give me lambda squared is equal to -4. When we solve for that, now we're going to get a complex solution. So that's going to give me a plus or minus 2i here. Okay, when we solve over here, we're going to get lambda is equal to -1. Okay? All right, we'll go ahead and write our equation based on this first. That's going to give me y is equal to c1 times e to the minus t. Okay, and then since we have complex, we're going to have to introduce the cosine and sine. That's going to give me plus c2 times the sine of 2t, and it really doesn't matter whether you write sine or cosine first, plus c3 times the cosine of 2t. That would be the solution to that differential equation. All right. Again, not bad at all. Just be careful when you have the plus or minus 2i's. Then you're just gonna go ahead and you go to the sine and cosine. If you have something like 2 plus or minus 2i, then you have to introduce the e. It'd be e. You'd put an e squared in here and an e squared in here. All right. Let's look at another one. Let's look at this differential equation here. We have 16y going to the 4th prime minus 8y double prime plus y is equal to 0. We're going to go ahead and solve that one. We're going to again use lambda. So we're going to write that as 16 lambda to the 4th minus 8 lambda squared plus 1 is equal to 0. Okay, the best way to solve a problem like that goes back to, I guess you probably would have learned this maybe in pre-calculus or algebra 2. You go ahead and multiply those two together. That's going to give you 16. Okay, and you think of what are the factors of 16 that add together that give you -8? That would be -4 and -4, correct? So we'll go ahead and rewrite this as 16 lambda to the 4th minus 4 lambda squared minus 4 lambda squared plus 1 is equal to 0. Okay, move this up. We'll go ahead and solve that. We group that first here, and I'm going to group it here. Pull greatest common out of here. That's going to give me a 4 lambda squared. Inside the parentheses, that's going to give me a 4 lambda squared minus 1. Now we want to get this to be the same. If I pull a -1 out, then I will have 4 lambda squared minus 1 is equal to 0. And now you can see where this is going. That's going to give me a 4 lambda squared minus 1 times 4 lambda squared minus 1. Alright, the good problem here, you can tell immediately you're going to get repeated roots with this particular problem. Alright, so let's go ahead and we're going to solve one of these. I'll take 4 lambda squared. We're going to set it equal to 1. We're going to move 1 to the other side. We're going to divide by 4. That's going to give me a lambda squared is equal to 1/4. Okay, I'm going to take the square root of both sides. That's going to give me lambda is equal to plus or minus 1/2. Okay, again, you got repeated roots because you have this one also going to have the same solution. So we have double roots. So we'll go ahead and rewrite this as our, not rewrite it, we'll go ahead and write our solution. So y is going to equal to c1 times e to the minus 1/2 t plus c2 times, and we'll go ahead and put another t in there, times t times e to the minus 1/2 t. Note the t is added because I have the double root. And we'll go ahead and continue. Plus c3 of e to the 1/2 t plus c4. Slide this over just a little bit. Plus c4 of, and I'll put the t in there, of e to the 1/2 t. So that's the solution to that differential equation. Again, not bad. Just be careful with the repeated roots and make sure you add in the extra t. Alright, let's look at one more on this video, and then later on I'll do the next video where we get into polars. Slide this down a little bit for you guys. Polars aren't too bad. It's a couple rule, just really one basic rule, and then it's really a piece of cake. Let's go ahead and solve this one. Again, let's rewrite this in terms of lambda. 16 lambda fourth plus 8 lambda squared plus 1 is equal to 0. Again, we're going to solve this, and it's solved it very similar I did before. I multiply the 16 and 1 together, and I think of what are the two factors of 16 that add together give me 8. That's going to be 4 and 4. I'm going to rewrite that as 16 lambda to the fourth plus 4 lambda squared plus 4 lambda squared plus 1 is equal to 0. Again, go ahead and just group this. Okay, pull the greatest common out of the left one. That's going to be a 4 lambda squared we're going to pull out. Inside, that's going to be a 4 lambda squared plus 1. We'll pull a 1 out of this one, plus 1 times 4 lambda squared plus 1. And again, you can see where we're headed. We're headed again with repeated roots, very similar to the problem before. 4 lambda squared plus 1 times 4 lambda squared plus 1. Okay, we'll go ahead and solve one of these. 4 lambda squared, we'll move the 1 to the other side, going to give me negative 1, and you can see right now we end up with a complex solution. We divide by 4, lambda squared is equal to negative 1/4. We take the square root of that. When we take the square root of that, we're going to get lambda is equal to plus or minus 1/2 I. So that's plus or minus 1/2 I. Immediately, we know we're going to go back to the cosine and sine. So our solution is going to be y is equal to c1 times the cosine of, we'll do the negative 1/2. We'll do negative 1/2 t plus c2, and we're going to bring the t down here of the cosine of negative 1/2 t. Hopefully I can get all this in one line. Actually, you know what, I'm going to go ahead and bring this on down. So that's going to give me down to here, and then let me shut this audio down. I'm not sure why that went off right now. Okay, so then we bring that on down, and that's going to give me c3 times the sine of negative 1/2 t. Okay, and then plus c4, we go ahead and put the t in of the sine, shouldn't put the parentheses, sine of minus 1/2 t. And that's going to be the solution to that differential equation. Again, not too bad. Okay, again, this is Dr. Holt. I've shown you guys about, I guess, 4 to 5 problems on this video. On the next one, we'll get into polar. Again, they're not too bad, a little bit more complex. Just you got to follow a basic rule, but again, they're not bad at all. Best of luck. I'll catch you on the next video.